The instrument panel vibrated with a deep, powerful rhythm that Lieutenant Sadamu Komachi had never felt before. It was the morning of July 16, 1944, and he sat in the cockpit of an enemy aircraft at Yokosuka Naval Air Technical Arsenal, his hands resting uncertainly on controls that felt both familiar and alien. The Grumman F6F Hellcat had been salvaged from the waters off Saipan 3 weeks earlier, plucked from the sea with its American pilot still strapped inside, dead from wounds that had nothing to do with the aircraft's structural integrity. Japanese salvage crews had worked with remarkable speed to transport it back to the home islands, and now it sat on the tarmac, its dark blue paint still bearing the white star of the United States Navy, a trophy that would soon reveal truths no one at Yokosuka wanted to accept. Komachi was not a test pilot by training. He was a combat veteran with over 400 hours in the Mitsubishi A6M0, a fighter pilot who had flown from carriers in the early days of the war when Japanese naval aviation seemed invincible. He had been at Pearl Harbor. He had escorted bombers over the Philippines and engaged American fighters in the skies above the Coral Sea. His superiors selected him for this assignment precisely because of his combat experience. They wanted a front-line pilot's assessment, not the clinical observations of an engineer who had never faced an enemy in combat. They wanted to know if the rumors were true, if the Hellcat was truly as formidable as the mounting losses suggested, or if American success was merely a matter of numbers, of throwing masses of adequate aircraft against Japan's qualitatively superior fighters. He had been told, repeatedly and with absolute conviction, that Japanese aircraft were superior. This wasn't propaganda meant for civilians. This was the technical doctrine that flowed from the Naval Air Technical Arsenal itself, from engineers who had designed the Zero, and the newer fighters meant to replace it. American aircraft were heavy, the engineers said. They sacrificed maneuverability for durability, agility for armor. They were flown by pilots with insufficient training. Men rushed through abbreviated programs, while Japan's aviators spent years perfecting their craft. The Zero could outturn anything in the sky. It could outclimb enemy fighters and operate at ranges that American designs couldn't match. These weren't empty boasts. They were facts proven in the war's early years, when Japanese fighters had swept Allied aircraft from Pacific skies with shocking ease. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But something had changed in the past year. Komachi knew it because he had lived it. American fighters had become more aggressive, more numerous, and somehow more effective. Zeros that had once dominated now fell in increasing numbers. Pilots returning from combat missions, those who returned at all, spoke in hushed tones about the Hellcat, about its speed and its devastating firepower, about how it could absorb punishment that would tear a Zero apart and keep flying. These reports filtered up through the chain of command, and eventually someone at Yokosuka decided that captured enemy aircraft needed to be studied not just on the ground, but in the air, flown by pilots who understood combat. The Hellcat's cockpit was cramped compared to the Zero's, but not uncomfortably so. What struck Komachi immediately was the sense of solidity, of mass surrounding him. The Zero felt like an extension of the pilot's body, responsive and light, almost fragile in its delicacy. The Hellcat felt like a fortress. The armor plate behind his seat was thick enough to see in his peripheral vision. The instrument panel was crowded with gauges that seemed redundant. Fuel pressure, oil pressure, manifold pressure, cylinder head temperature, each with its own dedicated dial. The throttle quadrant on the left side was substantial, mechanical, nothing like the elegant simplicity of Japanese controls. Everything about the aircraft suggested weight, protection, power. The engine was a Pratt & Whitney R-2800 Double Wasp, an 18-cylinder radial that displaced 2,800 cubic inches and produced 2,000 horsepower. Komachi knew these specifications because engineers had crawled over every inch of the aircraft, documenting everything, measuring and photographing and testing. The Zero's Nakajima Sakai engine produced barely 1,000 horsepower. The difference wasn't subtle. When Komachi advanced the throttle during his pre-flight checks, the Hellcat's engine didn't just respond. It roared, a deep, thunderous sound that made the entire airframe shudder. The propeller, a massive 13-foot Hamilton Standard unit, bit into the air with authority. Even stationary, the aircraft felt powerful in a way that Japanese fighters simply didn't. He had studied the technical reports. The engineers had been thorough, almost obsessively so, because what they were discovering contradicted everything they thought they knew about fighter design. The Hellcat weighed over 9,000 pounds empty, nearly twice the weight of a Zero. It should have been slow, clumsy, easy prey for Japan's nimble fighters. But the captured aircraft's performance data told a different story. In American hands, the Hellcat could reach 380 miles per hour at 17,500 feet. It could climb at better than 3,000 feet per minute initially. It could dive at speeds that would tear the wings off a Zero. And it carried 650 caliber machine guns, each loaded with 400 rounds of ammunition, a volume of firepower that seemed almost wasteful compared to the Zero's two 20mm cannons and two rifle-caliber machine guns with their carefully rationed ammunition loads. The ground crew chief approached the cockpit, a veteran mechanic who had worked on every type of Japanese naval aircraft in service. "The engine has 20 hours on it since we salvaged it," he said, speaking loudly over the idling radial. "No issues. Oil pressure is steady. The Americans maintain their aircraft well." There was something in his tone, a note of reluctant respect that Komachi recognized. The ground crews saw things that pilots sometimes missed. They understood machines in ways that went beyond flying them. And this mechanic, this man who had probably serviced hundreds of Zeros and worked on the newer designs coming from Mitsubishi and Kawanishi, was impressed by American engineering. That alone was worth noting. Komachi signaled his readiness. The wheel chocks were pulled clear. He advanced the throttle slowly, feeling the Hellcat begin to move, and was immediately struck by how solidly it tracked. The Zero's narrow landing gear made ground, handling, and exercise in constant correction, but the Hellcat's wide-set gear kept it stable and straight. He taxied to the runway, going through the final checks, noting how everything felt heavier, more substantial, more deliberately engineered than any Japanese aircraft he had flown. The control tower cleared him for takeoff. Komachi aligned the Hellcat with the runway center line, took a breath, and pushed the throttle forward to its stop. The engine's roar became overwhelming. The massive propeller pulled the aircraft forward with shocking acceleration. The tail came up almost immediately, improving visibility over the nose. The Hellcat accelerated faster than a Zero, reaching flying speed in what felt like impossibly short distance. Komachi eased back on the stick, and the aircraft leaped into the air, climbing steeply without any sense of strain or hesitation. His mind, trained by hundreds of hours in Japanese fighters, struggled to process what was happening. This wasn't how heavy aircraft were supposed to behave. He raised the landing gear and felt the aircraft accelerate further as drag decreased. The rate of climb indicator showed 3,000 feet per minute, then held steady as he maintained the recommended climb speed of 125 miles per hour. A Zero could climb at 3,500 feet per minute initially, but only by sacrificing speed and putting strain on its engine. The Hellcat climbed effortlessly, its powerful engine pulling the heavy airframe upward with reserves of power still untapped. Komachi leveled off at 10,000 feet, and advanced the throttle to cruise power, watching the airspeed indicator climb past 250 miles per hour. The aircraft was smooth, stable, requiring minimal control input to maintain altitude and heading. It flew like it was riding on rails. He began a series of gentle turns, getting a feel for the controls. The Hellcat responded predictably, without the hair trigger sensitivity of the Zero, but also without any sense of sluggishness. The controls were harmonized. Aileron, elevator, and rudder all required similar pressure, making coordinated flight intuitive. He tightened the turn, increasing bank angle, and felt the G-forces build. The Hellcat turned well, better than its size suggested it should, though not with the instantaneous response of a Zero. But there was something else, something that took him a moment to identify. The Hellcat felt stable throughout the turn, as if it wanted to maintain the bank angle and turn rate he had established. The Zero required constant input, constant attention. This American fighter felt like it could practically fly itself. Komachi climbed to 17,500 feet, the altitude where the Hellcat supposedly reached its maximum speed. The air was thin and cold. Through the canopy, another feature that impressed him with its clarity and lack of distortion, he could see the coastline of Honshu stretching below, the countryside patchwork of rice paddies and villages that seemed impossibly peaceful given the war that was consuming the Pacific. He leveled off, let the aircraft stabilize, then advanced the throttle to maximum continuous power. The engine responded instantly, the manifold pressure gauge climbing to 46 inches of mercury, the cylinder head temperature rising but staying well within limits. The airspeed indicator began to climb. 260 miles per hour, 280, 300. The Hellcat accelerated smoothly, without vibration, without any sense that it was approaching its limits. 320, 340. The airspeed kept increasing. 360, 370. The needle finally stabilized at 378 miles per hour, just shy of the published maximum speed, but close enough that Komachi understood the specification was accurate. He was flying faster than he had ever flown in his life, faster than a Zero could fly in level flight even at its optimal altitude, and the Hellcat felt rock solid, stable, controllable. There was no buffeting, no warning that he was pushing the aircraft beyond its design envelope. It was simply fast, and it felt like it could maintain this speed indefinitely. He thought about combat, about what this speed meant in practical terms. A Zero at full throttle could reach perhaps 350 miles per hour in a shallow dive at this altitude, but only briefly, only by pushing the engine to limits that would reduce its lifespan. The Hellcat could cruise at speeds that required a Zero to strain. In combat, this meant American pilots could choose when to engage and when to disengage. They could dive in, make an attack, and extend away before Japanese fighters could respond. The speed advantage wasn't marginal. It was overwhelming. It changed everything about fighter tactics. Komachi began a shallow dive, letting the airspeed build further. 400 miles per hour, 420. The Hellcat remained stable, the controls still responsive, the airframe solid. He knew from technical reports that the aircraft was stressed to handle 7.5 Gs positive, 3.5 Gs negative. The Zero's lighter structure could barely manage 6 Gs before risking structural failure. He pulled back on the stick, converting speed to altitude, and felt the G-forces build smoothly. The aircraft responded precisely, climbing in a graceful arc that brought him back to 20,000 feet. His vision narrowed slightly from the G-load, but the Hellcat never wavered, never showed any sign of stress. It was built to be thrown around the sky by pilots who didn't need to baby their aircraft, who could fight aggressively without worrying about overstressing the airframe. He tried aerobatic maneuvers, rolls, loops, split S reversals, and found the Hellcat capable, if not spectacular. It would never outturn a Zero in sustained combat, but it didn't need to. The entire design philosophy was different. American engineers had built a fighter that could take punishment, that could dive away from trouble, that could use speed and altitude to control the terms of engagement. They had built it around pilot survival, around bringing men home even when their aircraft took damage. The armor plate, the self-sealing fuel tanks, the rugged construction, all of it made sense now that Komachi was flying the aircraft. This wasn't a fighter designed to win through agility. It was designed to win through attrition, through keeping American pilots alive long enough to learn, to improve, to eventually overwhelm their opponents through sheer accumulated experience. He descended back to lower altitude and explored the Hellcat's low-speed handling. The stall came cleanly at around 75 miles per hour with power off, with clear warning from buffeting. With power on, the aircraft would hang on its propeller at speeds that would leave a Zero wallowing. The controls remained effective throughout, and recovery was straightforward. Reduce angle of attack, add power, regain airspeed. There were no evil tendencies, no surprising behavior. The aircraft felt honest, predictable, forgiving. It was a fighter that could be flown by pilots with limited training and still be effective. That realization hit Komachi hard. Japan was losing its experienced pilots at an unsustainable rate. Replacements were arriving at frontline units with minimal training, sometimes less than 300 hours total flight time. These barely trained pilots were being sent to fly aircraft that demanded precision and skill. The Americans were doing the opposite, building aircraft that could be flown effectively by less experienced pilots while their veterans grew more skilled with each mission survived. He lined up for landing, reducing power and lowering the landing gear. The hydraulic system operated smoothly, the gear locked down with solid green. Indicators. He extended the flaps in stages, feeling the aircraft slow predictably at each increment. The approach was stable, the visibility over the nose adequate with the tail low attitude. The Hellcat desettled onto the runway with barely a bounce, the wide landing gear absorbing the touchdown forces. Komachi reduced power and applied the brakes, another feature that impressed him with their progressive, powerful response. The Zero's brakes were marginal at best, requiring careful modulation to avoid skidding. The Hellcat's brakes felt like they could stop the aircraft in half the distance, another small detail that spoke to comprehensive engineering. He taxied back to the apron where engineers and observers waited, their faces showing anticipation mixed with something else, apprehension perhaps, or the reluctance of men who suspect they're about to hear unwelcome truths. Komachi shut down the engine, the big radial coughing and falling silent, and sat for a moment in the sudden quiet, trying to organize his thoughts into something coherent. Everything he had been taught about fighter design, every assumption about Japanese technical superiority, had just been challenged by 37 minutes of flight time. The debriefing lasted 3 hours. Commander Minoru Genda, one of Japan's most respected aviation tacticians and a key planner of the Pearl Harbor attack, led the questioning. Other senior officers attended, along with engineers from the technical arsenal and representatives from Mitsubishi and Nakajima, Japan's primary aircraft manufacturers. They wanted details, specific performance numbers, handling characteristics, pilot workload, combat implications. Komachi provided everything they asked for, trying to remain objective, sticking to observable facts rather than impressions. The published performance specifications are accurate, he told them. 380 miles per hour at 17,500 feet. Rate of climb exceeds 3,000 feet per minute initially. The aircraft is stable throughout its flight envelope. Controls are well harmonized. Visibility is excellent. The engine produces tremendous power with no apparent strain. But surely it cannot maneuver with our fighters, one of the Mitsubishi engineers interjected. The weight penalty must be severe in turning combat. Komachi chose his words carefully. In a sustained turning engagement, the Zero retains an advantage. But the Hellcat's roll rate is superior. Its dive speed is much higher. And its speed advantage in level flight means American pilots can dictate the terms of engagement. They don't need to turn with us. They can attack from above, dive through our formations, and extend away before we can respond. The room fell silent. These were men who understood aviation, who knew exactly what Komachi's assessment meant. Commander Genda leaned forward. What is your evaluation as a combat pilot? If you encountered this aircraft in battle, flying a Zero, what would be your tactical approach? I would try to force a turning engagement at low altitude, where the Zero's lighter wing loading provides an advantage, Komachi replied. I would avoid diving engagements entirely. I would not attempt to chase the Hellcat in level flight because it's faster than we are, and I would be extremely cautious about attacking from below because the Hellcat can climb away faster than a Zero can follow. So the reports from the front are accurate, Genda said quietly. The Hellcat negates our traditional advantages. Yes, sir, but there's something else. Komachi paused, knowing his next words would be even more unwelcome. The aircraft's construction quality is extraordinary. Every system functions smoothly. The engine runs cleanly with no vibration. The controls are precise. The landing gear is robust. This isn't a prototype or a limited production aircraft with hand-fitted parts. This is a production fighter, one of hundreds or thousands, and it's built to a standard that exceeds our finest aircraft. The Americans aren't just building better fighters. They're building them in quantities we cannot match, and every single one appears to be manufactured to exacting standards. One of the Nakajima representatives shifted uncomfortably. Our production methods are inadequate, Komachi interrupted, knowing he was being insubordinate but past caring. Sir, I've flown Zeros built in 1941 and Zeros built in 1944. The quality has declined noticeably. Control surface gaps are larger. Engines require more maintenance. Systems are less reliable. We're building aircraft as fast as we can, but we're sacrificing quality for quantity, and we're still producing fewer aircraft than the Americans, while their quality remains high or improves. I'm not an engineer, but I'm a pilot who has just flown an enemy aircraft that is simply better than ours in almost every measurable way. The debriefing concluded without any formal response to Komachi's assessment, but he could see the impact on the faces around the table. These were intelligent men who understood the implications. Japan's aerial superiority, such a decisive advantage in the war's early stages, had evaporated. The Americans had not just caught up, they had surpassed Japanese aviation technology, while simultaneously outproducing Japan's aircraft industry by ratios that were difficult even to calculate. Over the following weeks, other pilots flew the captured Hellcat. Each returned with similar assessments. The Naval Air Technical Arsenal produced a classified report that circulated among senior officers and government officials. The report was meticulously detailed and brutally honest. American fighter aircraft had achieved technical superiority across virtually every performance metric that mattered in combat. Speed, climb rate, dive performance, structural strength, armament, protection, reliability. In each category, the Hellcat matched or exceeded Japanese fighters, and this was just one aircraft type. Intelligence reports indicated the Americans were also producing the P-38 Lightning, the P-47 Thunderbolt, the P-51 Mustang, the F-4U Corsair, multiple fighter designs, each formidable, each being manufactured in staggering numbers. Komachi requested and received permission to fly the Hellcat again, this time in mock combat against a Zero, flown by another experienced pilot. The engagement was illuminating and depressing in equal measure. The Zero pilot attempted every tactical approach in Japan's combat doctrine. He tried to force turning engagements, attempted vertical scissors maneuvers, used the Zero's superior climb rate to gain altitude advantage. None of it mattered. Flying the Hellcat, Komachi could simply accelerate away from any unfavorable situation. He could dive out of danger, knowing the Zero couldn't follow without risking structural failure. He could climb at speeds that kept the Zero from gaining angles for deflection shots. When he chose to engage, he could attack from positions of advantage and disengage before the Zero pilot could respond effectively. The mock combat lasted 20 minutes and ended with both pilots understanding that tactics developed for the Zero were obsolete against American fighters. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The captured Hellcat remained at Yokosuka throughout the summer and into the fall of 1944, a trophy that became a teaching tool, then a source of demoralization. Pilots rotated through to fly it, and each came away with the same conclusions. Engineers studied it obsessively, measuring every dimension, testing every component, trying to understand how American industry could produce such sophisticated machinery in such quantities. They disassembled the engine, marveling at the precision of the machining, the quality of the materials, the sophistication of the supercharger system. They examined the hydraulic systems, the electrical systems, the radio equipment, all of it well-designed, well-manufactured, reliable. Attempts were made to apply lessons learned from the Hellcat to Japanese fighter development, but the gap wasn't merely technical, it was industrial and economic. Japan lacked the aluminum production capacity to build heavy fighters like the Hellcat in meaningful numbers. The nation's engine manufacturers couldn't produce 18-cylinder radials reliably at the power outputs American engines achieved routinely. The machine tool industry couldn't support the precision manufacturing visible in every component of the captured aircraft. Even if Japanese engineers designed aircraft matching American performance, the industrial infrastructure to produce them at scale simply didn't exist. Komachi flew combat missions throughout the remainder of 1944, still in Zeros, because that's what was available. Each mission brought encounters with American fighters, and increasingly those fighters were Hellcats. He survived by being cautious, by avoiding engagement unless conditions were overwhelmingly favorable, by using altitude and sun position to maximum advantage. He saw younger pilots, men with limited training, attempt to dogfight with Hellcats and die for their bravery. He saw American formations that could simply ignore Japanese fighters if they chose, completing their missions and returning to their carriers without bothering to engage targets they could easily avoid. The psychological impact was corrosive. Japanese pilots had begun the war convinced of their superiority. Now they flew knowing each mission might be their last, not because of enemy skill, though American pilots were improving rapidly with each month of combat experience, but because enemy aircraft were fundamentally superior to their own. By December of 1944, Lieutenant Komachi had logged over 700 hours of combat time. He had survived engagements that killed most of his original squadron. He had been promoted twice and decorated for valor. None of it meant much anymore because the mathematics of attrition were inescapable. Japan was losing pilots faster than they could be trained. and aircraft faster than they could be produced. The Americans were doing the opposite, improving training programs, fielding better aircraft, accumulating combat experience across an expanding pilot force. The captured Hellcat at Yokosuka had revealed these truths with clarity that no amount of propaganda could obscure. On December 14th, exactly 5 months after his first flight in the Hellcat, Komachi led a flight of 6 Zeros on a defensive patrol over Tokyo Bay. American carrier aircraft had been spotted approaching from the east, B-29 bombers escorted by fighters. His flight climbed to intercept, reaching 25,000 feet, and encountered a formation of Hellcats flying top cover for the bombers. The American fighters had altitude and speed advantage. They dove through Komachi's formation in a single slashing attack, their .50 caliber guns ripping into the Zero fighters with devastating effect. 2 of his aircraft fell immediately, one exploding in midair, the other spinning earthward, trailing smoke and flame. The surviving Zeros broke formation, each pilot maneuvering desperately to avoid the American fighters now pulling up to attack again. Komachi rolled inverted and dove, trading altitude for speed, knowing from his test flights in the captured Hellcat that this was the only escape tactic that offered any chance. His Zero accelerated past 350 miles per hour, the airframe beginning to buffet, the controls growing heavy. He pulled out at 10,000 feet, his vision graying from the G-forces, and looked back to see Hellcats still above him, not pursuing, because they didn't need to. They had altitude, energy, and the option to engage or not as they chose. His radio crackled with distress calls from his surviving pilots. Another Zero was hit and going down. The engagement had lasted perhaps 90 seconds, and half his flight was gone. He returned to base alone, his Zero untouched except for minor damage from debris when one of his wingman's aircraft exploded nearby. The other 4 pilots in his flight were dead or missing, and he hadn't fired a single shot at the enemy. In his after-action report, he wrote simply that American fighters were operating with impunity, that Japanese defensive capabilities were inadequate, that losses would continue to mount until either tactics or equipment changed fundamentally. His commanding officer read the report without comment and filed it with dozens of similar assessments from other surviving pilots. The reality was that nothing would change, nothing could change. Japanese aircraft production in 1944 totaled approximately 28,000 aircraft of all types. American production the same year exceeded 96,000 aircraft. Of those, over 12,000 were F6F Hellcats alone, more Hellcats in 1 year than Japan's entire fighter production, and the Hellcats were just one type among many. The P-38, P-47, P-51, and F-4U were all in large-scale production, each a formidable fighter, each being manufactured in quantities that dwarfed Japanese output. The disparity wasn't in individual aircraft quality anymore. American designs had surpassed Japanese performance. The disparity was in industrial capacity, in the ability to design, manufacture, and field weapons systems at a scale Japan simply could not match. The captured Hellcat at Yokosuka became almost a shrine of sorts, a physical manifestation of uncomfortable truths that could no longer be denied. Pilots who flew it came away shaken, not by fear of the aircraft itself, but by what it represented. This was a production fighter, one of thousands, and it had been built with a casual excellence that suggested the Americans weren't even trying particularly hard. The quality control was simply standard. The engineering was simply normal American practice. And if this level of sophistication was routine, what else were they capable of producing? Lieutenant Commander Yoshoshiga, another veteran pilot selected to evaluate the Hellcat in early 1945, spent 3 flights putting the aircraft through increasingly aggressive maneuvers. On his final flight, he pushed the Hellcat to its structural limits, pulling 7G turns, diving past 450 miles per hour, performing violent rolling maneuvers that would have torn a Zero's wings off. The Hellcat absorbed everything without complaint, without warning signs of impending failure, without any indication that he was approaching actual limits. After landing, Shiga walked around the aircraft with engineers, examining the wings and control surfaces for any signs of stress or deformation. There were none. The aircraft was structurally sound, ready to fly again immediately. "How many flight hours does this airframe have?" Shiga asked one of the engineers. The engineer consulted his logbook. "Approximately 130 hours before capture, based on the maintenance logs found with the aircraft. Another 90 hours since we've had it. Total of 220 hours. Shiga looked at the Hellcat's engine cowling, still bearing its American markings. And the engine, same. The Americans change engines at regular intervals, regardless of condition, so this one was likely halfway through its service life when we captured it. We've run it hard here. Full power tests, maximum performance flights. Oil analysis shows minimal wear. Cylinder compressions are all within specifications. This engine could easily fly another 200 hours or more. 200 hours more. Shiga thought about Zero engines, which required major overhaul at 300 hours, if they lasted that long. He thought about the declining quality of Japanese engines as the war progressed, as skilled machinists were drafted into combat units, as material shortages forced the use of inferior alloys, as production demands prioritized quantity over quality. The Hellcat's engine was built to tolerances that Japanese manufacturers couldn't reliably achieve even in peacetime, and it was just one component of an aircraft system that demonstrated American engineering and manufacturing superiority at every level. The psychological impact on Japanese pilots extended beyond those who flew the captured Hellcat. Word spread through the Naval Air Service about the evaluations, about what experienced pilots were saying, about the performance comparisons that couldn't be dismissed as propaganda or exaggeration. Pilots who had never seen the captured aircraft still knew it existed, still heard the stories, still understood what it meant. The Americans had better fighters. They had more of them, and they were getting better while Japanese capabilities declined. Komachi watched this demoralization spread through his unit during the early months of 1945. New pilots arrived with minimal training, some with less than 100 hours total flight time, thrust into cockpits and sent to fight against American pilots who had accumulated hundreds of combat hours in superior aircraft. The mathematics were brutal. A barely trained pilot in an inferior aircraft facing a well-trained pilot in a superior aircraft had essentially no chance of survival. Tactics didn't matter. Courage didn't matter. The material disparity was too great. By March of 1945, American carrier task forces were operating within sight of the Japanese home islands with impunity. Fighter sweeps over Japanese airfields destroyed aircraft on the ground because attempting to intercept was suicide. The few Japanese fighters that did manage to get airborne were swatted from the sky by overwhelming numbers of Hellcats, Corsairs, and other American fighters. Japanese losses in individual engagements sometimes reached 90% or higher. The Americans lost pilots too, but at ratios that were sustainable, replaceable. Japan's pilot losses were catastrophic and irreplaceable. Komachi flew his last combat mission on March 19, 1945, during American strikes against targets near Kobe. His flight of 8 Zeros intercepted a formation of over 40 American aircraft, dive bombers, torpedo bombers, and at least 20 Hellcats flying escort. The engagement was hopeless from the start. American fighters dove through the Japanese formation in coordinated attacks, their 650 caliber guns per aircraft creating walls of fire that no Zero could survive. Within minutes, 5 of Komachi's 8 aircraft were shot down. The remaining 3, including Komachi, dove away and scattered, unable to even threaten the American bombers that continued to their targets unmolested. Komachi's Zero took hits in that engagement. 20-millimeter cannon rounds from a Hellcat that had briefly gotten on his tail before he managed to escape into cloud cover. The rounds punched through his left wing, destroying the aileron and damaging the main spar. That he made it back to base at all was more luck than skill. The Zero's light construction, once considered an acceptable trade-off for performance, meant that any battle damage was likely to be catastrophic. American fighters could absorb hits that would down a Zero and keep flying. Komachi had seen it himself during his evaluation flights in the captured Hellcat. The thick armor plate, the self-sealing fuel tanks, the robust structure. Everything designed to bring the pilot home. His damaged Zero was scrapped after that mission. There weren't enough spare parts to repair it, and the aircraft's airframe hours were approaching limits that made major repairs pointless. Komachi was grounded, transferred to a training unit where he spent the remaining months of the war attempting to teach barely educated farm boys and factory workers how to fly aircraft that most of them would never master before dying in combat. The frustration was overwhelming. He knew what American pilots were flying. He knew the training American pilots received. Months of instruction in safe, structured environments with fuel and aircraft to spare for practice. Japanese pilot training by mid-1945 was measured in weeks. Students flew worn-out aircraft with engines that might fail at any moment. Fuel shortages meant minimal flight hours. Many pilots were sent to operational units with less time in cockpits than Komachi had accumulated in the single captured Hellcat during his evaluation flights. The Hellcat at Yokosuka continued to be studied even as the war entered its final months. Engineers had moved beyond simply documenting its features to attempting reverse engineering of specific systems. But the exercise was largely academic. Japan lacked the industrial capacity to implement what they learned. The Hellcat's sophisticated supercharger system required precision casting and machining beyond Japanese capabilities. Its electrical system used components and materials that weren't available. Its hydraulic system operated at pressures that Japanese seals and fittings couldn't reliably maintain. Even simple things like the quality of the aircraft's aluminum alloys represented manufacturing standards Japan couldn't match with its degraded industrial base and resource shortages. One of the engineers, a man named Horikoshi who had worked on Zero development, sat with Komachi one afternoon in May of 1945 and spoke with unusual candor. "We knew the Americans had industrial capacity," Horikoshi said. "We knew their production numbers would exceed ours. What we didn't anticipate was that they would also achieve technical superiority. We assumed we could maintain a qualitative edge, even if we lost the quantitative battle. The Hellcat proves we were wrong. It's not just that they build more aircraft. They build better aircraft, and they do it at scale. Every Hellcat that rolls off their production lines is as well made as the one we captured. That level of consistency, that manufacturing quality across thousands of units, we've never achieved it, not even in peacetime." "Could we have?" Komachi asked. "If we'd known in 1941 what we know now, could we have built something equivalent?" Horikoshi considered the question carefully. Perhaps one prototype, or a small production run with hand-selected materials and craftsmen. But mass production? No. Our industrial base couldn't support it. We lacked the machine tools, the raw materials, the electrical power generation capacity, the transportation infrastructure. The Americans have all of that, and in abundance. They can design an aircraft like the Hellcat, and have it in mass production within a year. We design aircraft and struggle to produce them in meaningful numbers even when the design is simpler. The gap isn't just in aviation, it's in the entire industrial ecosystem that supports aviation. That conversation stayed with Komachi through the war's final months. The captured Hellcat was more than just an enemy aircraft. It was evidence of a fundamental miscalculation that had doomed Japan's war effort from the beginning. Japanese military planning had assumed that superior training and fighting spirit could offset material disadvantages, that the psychological and tactical superiority of Japanese forces would overcome American industrial capacity. The Hellcat demonstrated that this assumption was fatally flawed. American aircraft weren't just more numerous, they were better. American pilots weren't just adequately trained, they were becoming highly skilled through combat experience that Japanese pilots rarely survived long enough to accumulate. American industrial capacity wasn't just larger, it was sophisticated enough to produce complex weapon systems with consistent quality at staggering scale. The war ended in August of 1945 with Japan's surrender. Komachi survived, unlike most of his fellow pilots from the war's early years. He had accumulated over 900 hours of combat time, an almost unheard-of total for Japanese naval aviators by war's end. Most pilots who flew even half that amount were dead. His survival was due partly to skill, partly to caution learned from experience, and partly to pure chance. In the immediate post-war period, American occupation forces interviewed surviving Japanese pilots extensively, documenting their experiences and gathering technical intelligence. During one such interview, Komachi was asked about the most significant factor in Japan's defeat in the air war. He thought about that question for a long time before answering. He could have mentioned pilot training or fuel shortages or the loss of experienced aircrew. All of those factors mattered. But his mind kept returning to that morning in July of 1944 when he had first flown the captured Hellcat, to those moments when he realized that everything he had been taught about Japanese aerial superiority was wrong. "We believed our own propaganda," he finally said. "We convinced ourselves that fighting spirit and tactical excellence could overcome material disadvantages. We assumed American aircraft were adequate but not superior. We thought American pilots were poorly trained and would fold under pressure. The Hellcat, one captured aircraft, revealed all of those assumptions to be false. It was faster than our fighters, stronger, better armed, better protected. And it wasn't a special aircraft. It was standard production, one of thousands. That single aircraft told us we had already lost the air war, but by the time we understood that, it was too late to change anything." The American interviewer, himself a former Hellcat pilot, asked a follow-up question. "When you flew the Hellcat, what surprised you most?" Komachi smiled slightly, remembering that it flew so well. "We expected it to be brutal, difficult, a brute force design that sacrificed refinement for power. But it was refined. The controls were harmonized. The systems worked smoothly. The engine was powerful but also smooth and reliable. It was an aircraft designed by engineers who understood both combat requirements and pilot needs, built by workers who took pride in their craftsmanship. Every detail was considered. Nothing felt like a compromise. That's what surprised me, that the Americans had built not just a powerful fighter, but a good one, and they had done it thousands of times over." Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.